Good morning.
Good morning, sir.
Yeah, just you can switch on your videos, just introduce yourself. See, just first class, I just wanted to see how many of them are there. Simple. Tell your name, that's all, right? Which department? Is there a difficulty?
Sir, Bhuneshwar, sir. F of.
Old. My students. Okay, fine. Kiran Kumar. Yeah.
Yes, sir. Good morning, sir.
Good morning. Right.
Myself, Kiran Kumar, sir.
Yeah.
I am from Andhra Pradesh, sir.
Yeah, don't worry. I'm not a pharmacy man.
Okay, sir.
So we'll have 1 hour. That's all, right? Yeah.
Okay.
Then anybody else? See, the trend
Good
is.
morning, sir.
So is there any chance of switching on your video?
Sir, there's some problem. I don't know. It's not
Fine,
switching
fine.
on.
Girls, we are not compelling to switch on your videos, no? Without makeup, you won't come. Yeah.
No, sir, I didn't mean that.
Yeah.
Good morning, sir. My name is Arpita Chakravarti.
Yeah. Right.
I'm from Department of Pharmaceutics.
Yeah, same. Fine. Right. Then we'll give another 2 or 3 minutes. How many of them are there actually?
15
Total.
students, sir.
15. Another 5 has to join. Right. Then Ananya Chaudhary, something.
Good morning, sir.
Yes. Venkat. Yes.
Good morning, sir. My name is Venkat,
Yeah.
and I'm from Hyderabad, sir.
Fine. Right. That's all. Anybody else?
Good morning, sir. I'm Abhishek, sir.
Yeah. Right. Fine. Yeah.
Yes, sir.
That's all.
Sir, hello, sir. Good morning, sir. Imran Khan, sir.
Yes.
I'm Imran Khan from JSS College of Pharmacy, sir.
Pata NGR.
No, sir. No, sir. இது சார் ஷாப்பிங்லாம் போயிட்டு வரோம் அந்த டயர்ட் சார் 12 o'clock 12 o'clock போயிட்டு வரோம் சார் க்ரோசரிஸ்க்குலாம்
Okay. 12 o'clock it's getting closed. Yes.
Yes, sir.
Right. Okay. Shall we start? Right. Okay.
Yes, sir.
Yes, sir.
Yeah. 1 or 2 people can be with me. Why it's echoing? Somebody. Jitendran, sir, mute.
Sir.
Jitendran, you can mute your mic. Yeah.
Sir.
1 or 2 people be with me so that it will be like a class. Otherwise, it will be boring. I'm going to share a screen. Just check it out whether you are getting it. You can see something on the screen.
Yes, sir.
Yes, sir.
Yes, sir.
That's good. Just be with me. Right. 1 or 2. See, I'm not going to bore you because this is already a boring subject. Nobody likes it anyway. It's already boring subject. There are 2 parts here. I don't know whether they have taken it or not. They told me to take this. Okay. So first of all, it is computers in pharmaceutical research and development. They said they will be completing it. Okay. They told me to take which one? This is right. Statistical modeling in pharmaceutical research and development, they told. Actually, so you can refer to the book which is prescribed to you. That is always better. So what we are going to do today is we will see the basics completely. What are all the things? Why should we use this? All these things we are going to have a basics. So then if you want another class, we can have for the advancement, how we are going to apply these things. Okay, so first you have to understand the basics, then only you can go for the application. Okay, so without knowing the basics, you cannot go for the application. That's the key. Yes. Okay, so In between, I'm going to ask some questions here, not related to your subject. Don't worry, right? So we will be doing this with your day-to-day life's example. Okay, then only you'll understand statistics and computers. Otherwise, it is very tough for you to understand. Okay, most of the time. Okay, so now shall we proceed?
Yes, sir.
Yes, sir. Yes,
Somebody,
sir.
one or two. See, you're not small kids. No, you're just like our colleagues only. So we treat all informed students as colleagues only. So we'll be having an interaction class. Okay, not what I am teaching you or learning. That method you just omitted. Okay, so that will not be a good one. So it should be an interactive one where we will share our knowledge. So you have studied already pharmacy. I have not studied pharmacy. So I'll be giving some example related to mathematics and you will be just relating it to your pharmacy field. Is it fine? Is it fine?
Yes, sir.
Right. Right. So why I am saying no, just be with me, right? So it's not a good one to just mute your mic and go somewhere and come after 11 o'clock and then study from the notes. That will not help you anyway, right? So we'll be going for the, right. So here, modeling. So what is this model? Okay, we'll go for a smaller example here. So if I'm going to write something on the board, just like in the screen, if you are not getting it, you just tell me. See, suppose there are three people, okay? See, for example, one, people number two, and people number three, okay? So they are very generous here, okay? These people are generous people, okay? There are 5 or 6 other people here, okay? Your friends only, okay? There are 5 people. For example, I'll take 5 people. This is A, is B, is C, okay? This A is taking all these fellows to biryani shop, okay? To get them biryani. So what will you additionally take with biryani? Anybody? Or what?
Any grilled chicken like that, sir.
Okay, grilled chicken. No, I'm talking about the liquid, not alcohol. Not alcohol.
Coke.
Yeah. Coke you are going to take. Biryani with Coke. So this fellow wants to find out. See, this fellow is giving all these 5 people biryani because of getting some productivity work. He's going to give him some productivity work. Who gives more output? That's what he wants to have. So what we are going to do is we are going to design a model. Okay, so that model will look like this. It has, for example, AX1 plus BX2 plus C. This is a constant. Here we are going to find out what is the value of C, what is the value of B, what is the value of A. See, for example, this X1 will be the biryani these people will be eating it. Okay, otherwise the price. And this is the price of the Coke. Okay. Now A will be some 5, for example. So 5 into 12. Okay, 120 rupees biryani cost plus 7 into 40 rupees is the Coke cost plus 75 rupees is the auto charge. Okay, this is what I'm going to calculate. So Y gives you some 750. For this boy, Y gives you some 1050. This is Y1, Y2, Y3. I'll have. This is 750 as usual, right? Plus 25 days. So we are spending this. So for him, these 5 people gives more productivity. For him, these people give more productivity. For him, those people will give more productivity. We are going to find out. Then that particular equation, we will be writing it here. Okay, Y is equal to A into 120, for example, plus B into 240 plus 7. This is the model. And this will be taken by all of the people who make these people productive. Okay, so now how it will come to the pharmaceutical industry here. Now I'm having ingredients 1, ingredient 2, ingredient 3, and the machine which is rotating, that is called the rotor, 50,000 revolutions per minute, for example, or second, whatever it is. Okay. Now for how much, this I'll take it as a powder. Okay. This I'll take it as a solvent or water-based something. This is extra solvent. See, by how much if I put, I will get the best result for the industry. So that is what is the thing. Okay, once this is being done using computers and statistics method, you will be getting an equation. Y is equal to 7x power 1 plus 4x power 2 plus 23. Like that, I'll get an equation. This equation will be given to the people to produce the medicine. That's all. This gives the optimal value. So this is called a model. Okay. So to get this equation, we will be doing a model. That model will be using throughout our company process to produce medicines, for example. Okay. So if it comes for pharmacology, so which is the best method to invent a drug? So we will be doing it. Is this particular point is clear? So if it is clear, we'll move on to the next one. It is very simple. So we are designing an equation. Okay. So this is nothing but a mathematical equation. This is nothing but a mathematical equation which gives you the optimal solution, so that we'll be using. So for designing this, we'll be having methods. We are having, so for example, factorial designs. We'll call it as factorial designs. We'll be having 2 square factorial design. We'll be having 2 cube factorial design. So many things are there. So using the design only, we'll be doing this. Okay, this is what we will be doing it. Is that clear? If it is clear, we'll move on to the next one. Anyone?
Clear,
Yes,
sir.
sir.
Yes.
So,
So
Yes, sir.
we'll move
Yes,
on.
sir.
See, so the same thing I'm going to do it as an example I'm going to give you. It's a very simple example. Don't break your head for calculations and all here. We are not going to go into the calculation here. So to design this particular model, I have selected one method. That method is called 2 by 2 factorials. Okay. So I'm using a factorial method to construct this equation. I'm coming to a conclusion. Okay. So now how usually we'll just convert this equation, that is called the statistical modeling. Okay, so now we'll quickly go on to an example. I'm going to give the same biryani example only. See, you just equate it to your pharmaceutical examples here. Okay, right. Now we are going to have estimate the productivity of 3 students. Productivity in the sense how many hours they are going to study, for example. Okay, that's called productivity. So only 2 things we are going to give them. One is bread. Okay. Another one is coffee. Okay, now here, how much bread I'm going to give, how much coffee I'm going to give for this 3 student. Okay, student 1, student 2, student 3, I'm going to give. Now, when minimum is 1 slice only I can give, maximum you can take 4 slices, then minimum 1 cup of coffee, maximum 4 cup of coffee you can. So now, if you mix this, these are all the variables now. These are all the variables or factors, we'll call it as variable 1, variable 2. So by mixing this in some combination, who gives the productivity? That is what we are going to design it. How to design this, for example. So whenever there is, I have got 2 factors. It's called factorial design. Don't break your head. They'll be teaching this in your pharmaceutical classes and all. Okay, other teachers will teach you. So I'm going to give a mathematical view on it. Right. So now this is called the factor 1. This is called the factor 2. Right. Now, whenever there is a minimum, I'll always denote it by minus. Whenever there is a maximum, I'll denote it by plus. So minimum is 1 slice, so it is denoted by minus, and maximum 4 slices denoted by plus. Okay, usually they'll write -1 and +1. Keep it in mind this one. Right now, coffee 1 cup is -4, maximum 4 cups. So me, Jay Kumar, I'll take 3 slices of bread, okay, and 2 cups of coffee. Then what is my productivity? And one of you, right, say Abhishek is taking 1 slice of bread and 4 cups of coffee. He wants to study more. Okay, so what is his productivity? We are going to find it out who produces more by giving this combination. That is what a pharmaceutical company will do. So mixing up these factors in what format will give you more productivity. Right? That's it. Is it clear?
Yes, sir.
Yes, sir.
We'll move on to this. So how we'll go about it? See, for example, we'll make this as A, make this as B. This AB is called the interaction between these 2. Okay. Now here I'm taking minimum of this one, minimum of this one. So I will call it as 1 only. Now, whenever there is A, that means A is taken more. Okay. So when A is taken more, A will be denoted here. That will be given by plus sign. So when B is taken more, B will be denoted. That will be denoted by plus here. When both AB are taking more, then it will be denoted by AB and it is given as plus. Now, I'm going to multiply this. I'll write this as the interaction. Okay, don't worry about this. This is called productivity. So student 1 and student 2, student 3. Okay, they have given a productivity of 3 and student 2 given a productivity of 4, student given productivity of 4. This is the data which I have observed. Okay, I'm using a computer-based program to find out these data. then these data will be tabulated. Okay, so now average, total, everything will be. So don't break your head for calculation here. I'm going to tell you what it is right now. Now, after finishing this, there are methods by which I am going to calculate the regression equation. The equation which comes like this, no, B0 plus beta 1 plus x1 like this, this is called a regression equation. I'm going to build a regression equation, or building a regression equation. This is the method. Okay, so this is the method I am adapting. This is the method. You may be adopting some other method. So which method suits for you and suits for the situation, that is called statistical modeling. Okay, after this, what I'm going to do is I will calculate everything. Then I'm going to design one model. Okay, this is the model I'm going to give it. Okay, now this model I'm going to calculate this value, this value, this value, this value. Then I'm going to substitute here in this value. I'll be getting the productivity results here. So from this result, I'm going for a conclusion, right? After doing all these things as it, okay, now what I'm going to give a conclusion, amount of bread you give to the student does not have significant effect, but amount of coffee gives more productivity. So those who are eating more bread will sleep. Okay, sleep. Those who are taking more coffee will give you more productivity. That is what I found out from this. Okay, this is how a model has been designed. So these are all the things, other things which will give you. There is no interaction between bread and coffee. Okay, we are coming to a conclusion. Then based on this, I am designing a model. Those model is called the statistical model. This will be given to the company to produce the medicine. That's all. Okay, so shall we move on to the, so this is the basic example by which you will be taking into mind. And when you read this book, you will understand most of the thing. Okay, so shall we move on to the next one?
Yes, sir.
Yes, sir.
Originally, we are moving for the this one. Okay, now this is what is your statistical modeling. Okay, now pharma industry, what it is needing now. Okay, now what is the challenge for the pharmaceutical industry? Okay, now whenever we go for a pharmaceutical industry, we need discovery and development. Usually, we want to have a discovery, new drug. Okay, Lux. Usually, we have a soap, right? Then for some time it was there. Then afterwards, new Lux, they will say. Okay, then fair and handsome, they say. Okay, so you will put fair and handsome, everybody will become handsome. Then that means in India, everybody should be looking handsome only. Now, I don't know whether it is working or not. So they'll be coming on to a new product. That's the challenge. Okay, now, whenever we go for the challenge, that should reduce cost and time. Okay, that should reduce time. Okay, cost and just excuse me. Okay, there was an online application problem. Right. Now, whenever we go for the new thing, it should reduce cost. It should reduce time needed from discovery. So suppose the need for our is, for example, COVID, right? COVID-19 vaccine, new. Okay, so I want to have a new one. So after 5 years, I'm going to find it out. It's of no use. Okay, so it's a challenge. So it should be reducing cost. It should be reducing right. Now, we should have some technology. New technology should be adopted. Now, technologies, new technologies have come to prepare drugs and all. See, now we are calling DOE. Okay, design of experiment is a new technology that we can use, right? So, new technology should be there. That is another challenge. Okay, now last one. It's nothing but we want to have an invention. New technology should be there to have a new invention. Now, according to your book, one particular thing is given as microarray technology was new, but the book was written very long back. Now, I think it is outdated anyway. They are telling like this, we are going to have microarray technology and a high throughput screening. These are all the method. These are all the new technologies which are being evolved in the pharma industry. That's what is given in the book actually. So what are all the new technologies you know now that you can write? Okay, right. Is it clear?
Yes, sir.
Right.
Yes,
So
sir.
next
Yes, sir.
we are moving on to the statistical modeling. So what I told you, just we are going to design a modeling. So what is it actually? Now, statistical modeling is nothing but a process. Okay. Now we are having a process. Okay. So which involves statistics in that. Okay. So a process which adopting a statistics to find out a model, which is always called as a mathematical model. See, whatever I gave, that question I gave, y is equal to 3x plus 2y plus c. If I have an equation, this equation, regression equation, we usually call it as, this is fit. Okay, so now preparing this is called the statistical model. Okay, now when to use this model? Why to use this model? Okay, now when data analysis apply various statistical models. So now, see, data analysts, see, who are these people? They will take data, they will go analyze it, and they will come as a solution to give the pharma company that if you prepare this like this, this will be marketed quick, this will be the best thing to use it. All these things, these people will tell, data analysts. Now, how they are finding out? Okay, by inventing this, change the color of the soap to green color, so it will go. And for girls, you just take the soap for pink color, so it will go fantastically. Just like that, they will find it out. How they are finding out? They are using some statistical models, okay, for investigating, and they will be able to understand the demand and they will interpret the result. Okay, so now statistical modeling, when to use it, right? Now, when we go for the see, what is this statistical model will do? See, for example, y is equal to 5x plus 2y plus 7. So it is building a relationship between these variables. These are all the variables. These variables may be dependent or independent, and giving a relationship between y and x. Okay, so it's going to build a relationship and give it to us. It's called the statistical modeling work. Okay, now a relationship between variables, make predictions. Based on this, I'm going to predict. Okay, this is what is going to happen like that. Okay, now about future sets of data. What are all these data I'm going to take it, and I will do the analysis and give it to the stakeholders. Okay, so that is what the statistician will do. Is it clear? This is called the statistical modeling. Fine.
Yes, sir.
Right. When we go for the descriptive modeling, okay, there are two types we are going to see today. One is descriptive, another one is mechanistic. Okay, so now what is called descriptive modeling? Descriptive is nothing but describing. Okay, so we'll be describing it. Okay, so descriptive modeling is nothing but a mathematical process. Okay, so it just some real world events. See, for example, COVID-19. Okay, what is the situation now? It describes, okay, so many percentage, okay, 50% of people, if they are get vaccinated, it will get reduced. Like that, I'm going to have the real world events, and I'm going to build a relationship between factors responsible for them. Okay, what is the factor which is responsible for the vaccine to be produced? Here is the virus which is causing COVID-19. Okay, so real world, I will take it, I will build a relationship. Okay. Now it is always consumer driven one. Okay, now consumer driven organization only will go for it, so that we will find it out. See, I'm doing a vaccine that nobody is going to get it, so that means it's a waste. So it should be consumer driven. Now cluster role. Cluster means, see, for example, Indians. Okay, so we are in one cluster. Okay, Americans, they are in one cluster. So in South Indians, North Indians, like that, the cluster. According to the cluster, we have to design. See, for example, food. If you go for food, okay, South Indians and North Indians. Okay, South Indians eat rice more. North Indians eat what when? Any North Indian is there?
Roti.
Yeah, they will. I see. I guessed correct. So roti. What is the spelling? ROTTI. Right. They will eat roti. So now, if you go and sell with a model for rice to all North Indians, a failure model. Okay. This is what is the cluster rule. Okay. So now, according to the cluster, we will be designing. Okay. Now, similar things. See, suppose I am using a with blue ink. Okay, so now what is my friends also using blue ink, for example. Okay, that is what similarities. So what everyone will see, I am taking Covaxin vaccine only. So all the JSS College Pharmacy, they took Covishield, for example. That's the similarity. Okay, and where they differ, they will find it. Okay, so keeping on all this method, we will be doing a modeling that's called the descriptive modeling. Is it fine?
Yes, sir.
So now we'll move on to the next one. What is the main aspects of this statistical descriptive modeling? Okay, now customer segmentation. That's what I said. Okay, now partitions a customer base into groups with various impacts on marketing and surveys. So I am going to market it. So what the customer is liking it based on their likings. Okay, now I will partition it. For example, I'm going to have a full customer of Indians, for example. I'm going to have South Indians, I'm going to North Indians, I'm going to have others. So they shifted from North India to South India. According to this only, I'm going to design this so that I will partition. For these people, this will be best. For these people, this will be best. For these people, this will be best. Okay, now that's called customer segmentation. Now, what is value-based segmentation? These are all the other aspects of descriptive modeling. So it identifies and quantifies the value of a customer to the organization. See, for example, I am having a customer for my organization. What is best for him, I have to do. If a pharmaceutical company is there, which is best for him, I'm going to identify him. I am going to give him the particular thing. Whenever I produce a drug, which is the best one, I'm going to allow it. So that's called value-based segmentation. This is a plant 1, for example. This is a plant 2. Here, this plant will work from 5 to 10. This plant will only work from 10 to 12 in the night. That's like I will segment it and use it. That is the main aspect of the descriptive modeling. Okay, now next one is behavior-based segmentation. So we have to customer product usage and purchasing patterns. We have to go for it, and behavior-based segmentation. We have to just split it into segments of behavior-based. So who will use? Okay, so most of the people will use tea. Okay, in Ooty, right? Most of the people will use coffee in Coorg, for example. So I have to differentiate this Ooty people with Coorg people so that I can produce the medicines or whatever is the consumer list as per this segmentation. Okay. Now, need-based segmentation. You know what is need-based. Okay, what is the need? According to that, I have to produce. Okay, now the need is vaccination. A company which is producing vaccination alone will survive in this. Okay, now if I am going to produce some beauty products, nobody is coming outside the house. Beauty products will not go. Even though people are doing makeup inside the house also, it's not going, right? Fine. So this is the main aspects of the modeling of your descriptive modeling. Okay, now we'll come for the next type, which is called the mechanistic modeling. Okay, so if you go inside the book, you know, it is given as a story here. So important points alone we have taken here, and it is useful for you, right? Now, when I go for the mechanistic modeling, what is it actually? So I am having a theory now. I'm having a theory. So most boys will like to have what is that? Sherwani. I don't know what is the dress which they are wearing in North side. So most of the South Indians will like to have Sherwani in their wedding, for example. Okay. Now, this is a theory. I got it. So now, based on this theory, I'm going to do a prediction. Okay. Now, if I prepare all black color Sherwani, it will move on very fast for the wedding of all South Indians. So suppose if I say like this, so this is called theory to prediction. Okay, now in mechanistic modeling, same thing is going to happen. From theory, I am moving on to the prediction. Okay, so you use a theory to make a prediction. Okay, now in drug development, what is it happening? Mechanistic modeling approaches can yield insights from data throughout the development process. Okay, so we'll be having a data. Using the data until we prepare the drug, this mechanistic modeling only will be useful, right? Now, mechanistic models are based on the fundamental laws of natural sciences. What are all the laws applicable to natural sciences? I have to use it, right? Physical and biomedical principle constitute the model equation. See, for example, I want to calibrate the model and determine unknown model parameter. Okay, now absorption coefficient, diffusivity or material properties for the preparation of that, I'll be using the mechanistic model. Okay, so it is different from descriptive model. Is it fine?
Yes, sir.
Yes, sir.
Yeah, fantastic. Right.
Yes, sir.
Then we'll move on to the next one, which is what is it? See, we have given some 2 or 3 only to understand what is the use of this one. Okay, I'm sorry. Now, what is the advantages and disadvantages? Instead of advantages, just we are going to compare it. Okay, don't say it as advantages and disadvantages. We are going to compare. Okay, now descriptive purpose is to provide a reasonable description. Here, the purpose is, see, the mechanistic model, the importance, knowledge of the device development will be used here. Okay, now here the model is chosen based on the competence. Okay, now here it is updated, strong, and true knowledge will be used to have the mechanistic model. Okay, so these are all the things, few things. I'll say I have not given everything here. It is a few things. Whatever you Google it, or you go for the books, you just find it out. Some are the methods or characteristics of descriptive versus mechanistic. So many things you can write. Okay, so now 5 points you can write out and finish it off. This one, descriptive versus mechanistic. What is the use? Right. Now, whenever we just wanted to construct statistics modeling, few things we have to remember. See, what is the statistics terminologies are used in the previous classes. You should have studied in biostatistics class while you are in B-Pharm. Most of them would have forgotten, right? See, and I will say whenever you are studying in B-Pharm, you would understand. Now you have come to a post-graduation. Now you know what is the, right? So I'm going to, one by one, I'm going to say what is the meaning of this. We'll quickly move on to this. Okay, so I will first start with what's called a parameter. Okay, now it is nothing but the summary description about a population. Okay, so I'm having a population. For example, JSS College, all the students, okay, are population. Okay, now students are the sample, for example. So I will describe the marks. Average mark is 75 per 100. Now I'm describing something about the population. Whenever I describe something about the population, is called the parameter. Now same thing, I am finding out 80/100 is for the SUTIC students alone. Then it's called the statistics. Okay, it describes something about a population. Then it is called as a parameter. When describes something about the sample, it is called the statistics. Okay, now one-tailed test and two-tailed test you have to be there. Okay, so now I want to check whether BP is differing. Okay, BP is differing when I'm doing animal test. Then I'll call it as it is two-tailed test. Differing means if it is less also, I will measure. If it is more also, I'll measure. Okay, less or more. Okay, then it is called two-tailed test. So whenever I go for a BP is increased or not, so I don't bother about whether it is decreasing or not. I want to find out 120 is my BP now, whether it is increased 130 or not. I don't want to take it as 110. So then it is called the one-tailed test. Okay. Now, whatever the calculation I am doing, that is called the test statistics. For example, T is equal to 5.3 is a test. T test I have done, I got a value. This value is called the test statistics. Okay. Now, standard error is nothing like, it is like standard deviation. What is this standard deviation? For example, say I'm having an average 50. Okay, so all the other values are here 5, 2, 4. Okay, now how my values are spread. Okay, that is what measured by the standard deviation. Okay, so standard error is also same thing. It measures the spread, but it measures inside the sample. Then it is called the standard error. When it is measure of spread inside the sample, it is standard error. Measure of the spread in population is called standard deviation. Are you able to follow this? These are all the basics here you should know before we move on to the next one. If you have any doubt, you ask me. Otherwise, say yes and we'll move on. Parameter,
Yes, sir.
statistics,
Yes, sir.
standard
Yes, sir.
error, one-tail test, two-tail test, and test statistics you should understand. Okay. So when we move on, the type 1 error. Okay. Type 1 error is called alpha. What is the type 1 error? I am making a statement. Okay. Now my statement is true. When somebody is rejecting it, then it is called type 1 error. Truth is neglected. You remember, okay? I am making a statement and it is being rejected, even though it is true, it's called type 1 error. Okay. I am making a statement, it is false, even though it is false, somebody is accepting it, then it is called the type 2 error. Type 1 error, truth is neglected. Type 2 error, the false is accepted. So I'm going to give one example now. You are going to tell what is it actually, whether it is type 1 error or type 2 error. Okay? Good medicine not in market. A good medicine which is not in the market. So what is the researcher made? Whether he made a type 1 error or type 2 error?
Type 1.
Type 1.
Why? Because it is good. Okay, it is true. Okay, good means it is true, but it has been neglected. Okay, so it is type 1 error. Can you give the same example for type 2 error?
So bad medicine is
Yeah.
in the market.
Right, that's bad medicine which is in the market. Bad means it is false. It is accepted in the market, so it is called the it is called the type 2 error. Now, sometimes we'll be come across something called power. Okay. Now, power is nothing but the probability of rejecting the type 1 error. See, for example, okay, when it is really true, it's called power. Okay, now type 1 error is rejected, so it is the power. Confidence level, we are going to learn this. Okay, confidence level and confidence interval. Okay, now confidence level means what? It indicates that the probability with the estimation of location of statistical parameter in a sample survey. It is also true for the population. It is 1 minus alpha. Okay, see, I'm going to estimate something which falls within the, for example, 95% of confidence level. What is the meaning of this? For example, there are 20 people and there is a chance, one chance. When there are 20 experiments I have done it, there is a chance of one where I will be making a mistake. Okay, that's called the confidence level. So if I say 95% of confidence level, the 20 experiments, one may be mistake, for example. Okay, assumption will be mistake. So similarly, confidence interval is nothing but from this range to this range, my value will be correct. So whatever the value comes inside this range, see 5 to 7, for example, within this range, my value comes, I'll accept it. That's called the confidence interval. Now, critical value, it's nothing but the calculation, what I'm doing it. Okay, that's the critical value. See, the, for example, what I'm saying, whenever I draw a diagram here, see, I'm going to draw a diagram. See, for example, I'm writing like this. So value comes within this. Okay, you will reject it. A value comes within this, you are going to reject it. Okay, will reject it, will reject it. Okay, some 5 to 10, the value comes it, you accept it. Okay, whenever I have like this is called the rejection region. Okay. Right. Now, these are all the basics you want to go. Right. Now, what is the parameter? I told you already, parameter tells you something about the population. Now, the success is denoted by P and failure is denoted by Q. This also may be taken as a parameter. Okay. Now, expected value of mu. Mu is from the population. This is nothing but a parameter. And standard deviation, how much your data spread. Your data spread over the mean. Okay. For example, that is mu. Okay. So how it is being spread, that's also called the parameter. Okay. Now, how to estimate the parameter? So, if you want to estimate the parameter for any one method, what you are having, you should be finding out what's called the estimation here. Okay. Now, estimation is nothing but the procedure. Okay. So you should understand estimation is nothing but a procedure Okay, used to calculate the value of some property of a population. I want to calculate the property of a population. I'll be using a estimation. Okay, there are two types of estimation. One is called point estimation, and another one is called the interval estimation. See, for example, confidence interval goes under interval estimate. When I go for mu, okay, that goes under point estimate. So this is how we'll estimate the estimate your parameters. Okay, now what is this point estimate is called? Okay, now a point estimate is nothing but a single number, just like mu is equal to 73. If I have like this, it is the single number. It is used to express the value of the property. Then what is it? It is nothing but a likely value. Point estimation, likely value for a parameter. Okay, it is likely. See, mu should be within 7 to 15. If I say like this, when I have 6, it is not valid. When I have 16, it is not valid. So that will tell you the valid value. Now, sample proportion P hat. So this we'll write like this. P hat, this is called as P hat. Okay, is the point estimator of P. Now, if I say X bar, it is, I'll always know this one, it is mean. Okay, these are all the things called point estimation. Okay, so when we go for the next one, interval estimate is nothing but the range. Okay, so from 5 to 10, I'm going to explain. Okay, so this is called in range. Confidence interval, I told you already. Okay, so now we'll be writing T plus TS. See, for example, and T plus or minus S if I write. So T plus S to T minus S, it should go. Okay, that's called the confidence interval. Okay, now this is what is the confidence interval. I'm going to omit it anyway. This I told you already, right? Now, what is this non-linearity at optimum? Okay, now non-linearity optimum is nothing but there are methods. Okay, so there are methods to find out the right. There are methods to find out the maximum degree of non-linearity that exhibits around the optimum. Say, for example, I'm having an equation. Okay, now there are methods for accessing the maximum degree. So those methods are called the optimum value. So before I do the research, I have to find out the optimum values, and I will go on to maximize the product. See, for example, I'm doing a drug preparing industry. So optimum solution which is going to give. Okay, so I'm going to find out. And if it is not, for example, plant 1, plant 2, plant 3, 3 plants are manufacturing. So where I'm getting the maximum value, I have to find it out. Whether P1 is identified, it's not giving the maximum, then I'll go for a alternate method, alternate algorithm to make it maximize. This is called the property. We are having it here. Okay, now last one, what we are going to have is called the sensitivity analysis. Sensitivity analysis is a tool used most of the time. This tool is used for financial modeling to analyze how different value independent variable affect a specific dependent variable. See, for example, I'm having a independent variable, that is the powder, for example, okay, and the solvent, for example, then the rotor movement. Okay, now this powder and solvent I can control. Okay, so now whichever I can control, it's the independent variable, which I am, see, this is independent, okay, which I cannot control. Okay, revolution 50,000 per second means that's all. We cannot make it as 480. I cannot control this independent variable. Now powder and solvent I can control it. Okay, this is called the dependent variable. So what I'm doing is I will adjust these two to get the correct size of the pellets. Okay, so that is what is the sensitivity analysis, and we will be using it. Okay, once a model has been fitted to the available data and parameter estimates have been obtained, two further possible questions. What is the question? How important is a single parameter? I'm having, see, if I put some 200 grams, I'll get 7 pellets. For example, if I fit this, how it is going to happen? Okay, for this only, I'll be using a sensitivity analysis to find out whether this is true or not. Okay, right. Last one is the optimal design. Optimal design is nothing but the same thing. Okay, so I am designing something whichever the equation gives you, the more optimal solution. Okay. Now, if before that, before I'll do an optimal design, I always take into consideration, I have to estimate, okay, estimate without bias, with minimum variance. So I'll be estimated, I'll be putting inside the equation and find out which is the design which gives you optimal value. Okay, so last one is population modeling. Population model is nothing but very simple. I'll tell you, or you will read it afterwards. Okay, population means, say for example, COVID-19 vaccine, I'm going to prepare it. Okay, now whether it is applicable to the human population, what is the effects, all these things will be based on the population. I'll design this model. Okay, that's called the population modeling. Okay, it's nothing but a mathematical model. See, for it is usually given to the population. We move on to the population and find out what is the requirement. We are designing a study and we will be consulting a modeling for the population. Okay, so it is nothing but the population modeling. Okay, now it will always measure the relationship between the subjects. Okay, now physiologic characteristic and observed exposure or response. Okay, so what is the exposure? What is the response? This and all you'll study when you are doing some the DOE procedures in your pharmaceutics class. Okay, so now keep it in mind, population modeling is nothing but it's used for the study of the population. Okay, now what is an example I can give? Evaluating effect of a specific drug on tumor growth in populistic rodent. See, for example, you'll be having a rat. Okay, now I am just giving a drug to produce a tumor to the rat. I'm going to read it. Okay, study this. Okay, now after this, I will design a model that will give to the pharmaceutical company to make the drug to the entire population. Okay, that's what, right? So this is what is your statistics part. So if you have any doubt, you can ask. Another 5 minutes. Come on to the video. Just you can, if you have any doubt, you can ask. Otherwise, we'll wind it up. If you want, I can share this presentation, but it is only minimal wordings. Everything is given in the presentation. If you want, I'll send it to Satya so that you can study this also. Okay, these are all the previous things also is there. If you want, I can send it to study. Otherwise, you can study from the book. If you have any doubt, you can ask. Otherwise, we'll wind it.
Can we have the book name, sir?
You want to see the book name, right? Yeah, fantastic. I'll show whether I am having a. No, do you have a syllabus with you? So it is given in the syllabus. Anyway, I don't know whether I am having it or not. I may be having it. There are 2 books. No, I think I'm having it somewhere else anyway. Anyway, most probably Satya is having that book. He only sent yesterday to me. In the syllabus, it is given below the name. Okay, so you can study that. Right? If there is any doubt, I can clear it. Otherwise, we'll wind. Yes. Any doubt?
No, sir.
No, sir.
Okay, right. Then
No, sir.
have a good day. Right. Be safe. Don't come outside. So if there is any possibility, we can have one more class. Okay. Yet. Thank you very much.
Okay, sir.
Thank you, 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 sir.
I'll be sharing this presentation to Satya, so he'll be forwarding it to you. Right.
Okay, sir.
Okay,
Thank you,
sir.
sir.
Okay,